Another part of doing regressions is finding the residual. Now the residual is the difference between the y value of the data, so of the scatter plot, and the corresponding y value of a model for the data set. So the corresponding value that's on the line of best fit. So the residual is basically the difference between the scatter plot data point and the same x value, the y coordinate, on the line of best fit. We're going to see that if the original point, the scatter plot point, is above the line of best fit, it's going to have a positive residual, and if it's below the line of best fit, it's going to have a negative residual. Now, you can find a residual by calculating, this is read as y minus y hat. So it looks like there's a little hat on top, where y represents the y value of the data set, so the scatter plot, and y hat represents the corresponding y value predicted from the model, so from the linear regression. So this point would be xy, and this point would be xy hat. The residual would be y minus y hat, which is why it's positive here, whereas here y minus y hat, that would give you a negative residual. So now we're going to use this example. Copy down this table onto a sheet of paper and make sure you have graph paper because we're going to plot those points here. So we're plotting our points on the scatter plot. If it's a word problem, you still need a title, label your axes, make sure you have arrows here and here, you have your y and your x. And then we're going to go to our calculator and we're going to type in those points. So we're going to type in the scatter plot that we see at the top. This one we're going to use later to find the residuals. We're going to type in to our L1 and L2 these values. So we press stat, press enter on edit. Now I have numbers typed in from the last example I did, so I'm going to go up so that L1 is highlighted, press clear, and then press enter. Never press delete on L1, L2, any of those. Always clear and then enter. Then I'm going to go back over to L1 and I'm going to type in my values. Now you can see that I have my values typed into L1 and L2, just like I had from the table. X goes in L1, Y goes in L2, and I want to do a linear regression. Now, first, because we've been switching back and forth between graphing equations and doing linear regressions, I'm going to press second stat plot. Right now my plot one is off. I'm going to press enter here. I'm going to turn it on. Make sure that it's on scatter plot, which it is. My X list is L1, my Y list is L2. You can change the color if you want, but I suggest not making it yellow because it's going to make it a little bit challenging to see. And then I'm going to do my regression. So I press stat, go over to calc, always number 4, and you can just press the 4 key. My X list is L1, my Y list is L2. Let's say somehow you accidentally deleted that. To get L1 back, you press second stat and put in L1. I want to store my regression equation in Y1, so I'm going to press vars, Y vars, enter on function, enter on Y1, and then I'm going to calculate. When I calculate, you see that I get this. Now, in the future, these types of questions will say round to the nearest 100th, 1000th, whatever the case may be. I'm going to say round to the nearest 100th. Which means R equals 0.94, and my regression equation would be y equals, well, the a value is 4.885, so the a value is 4.89 to the nearest 100th, so 4.89x, plus the b value is 64.640, so 64.64. So now I have my correlation coefficient, which it's close to +1, so it's a strong positive correlation, and I have my line of best fit. Now with my line of best fit, so you should now have a scatter plot. You can count whatever interval is easiest for you on the y-axis, but the x-axis is easy enough to count by ones. On my graph, I am now going to graph the equation y equals 4.89x plus 64.64. I'm going to graph this on the same graph. And now you can see I have my scatter plot and I have my linear regression. Keep in mind I don't have it on this table, but it should have arrows going in this direction. If you're talking about a real life situation, like the number of hours or something like that, then it would only be in the first quadrant though. But there should be an arrow showing that it goes on forever. So now we have our correlation coefficient. We have our line of best fit. We have them both graphed on the same graph. Now we want to talk a little bit about residuals. Talking about residuals, so we want to, looking at this graph, see the difference between the point, the data point, so 170, and the point on the line. Well, since my equation is in y equals, and this is the unrounded equation, since my equation is in y equals, when I go to my table, we can see all of the points on the graph. So we can see that at 1, it's 69.526. But rather than calculating each one, rather than doing 70 minus 69.526, and then 68 minus whatever it is when x is 1.5, there is a way to get the calculator to do this for you. Now in order to do this, we're going to go back to Stat, and we're going to go back to Edit. Now once this is done, you probably won't have to redo it again, but you're going to go up to the L's, and you're going to go all the way right past L6. It should say Resid. If it doesn't, you press second, Stat, and you enter in whichever number says Resid, which in this case I have. And you should have these numbers show up. So I'm going to copy the y values for the corresponding x values, so the x values stay the same, but I'm going to copy the y values into my table, and since I'm doing everything to the nearest hundredth, I'll copy for the residual into the nearest hundredth. Then, usually it doesn't have to be on a separate graph, but for our purposes right now, we're going to do them on a separate graph. You're going to plot those points. So on graph paper in your notes, you're plotting these points. Now we can see that they're very random, meaning that the residual is different. There's no pattern to it. These points are close, this point is a little farther away from the line, a little farther away, this point is closer, closer, closer. So there's no pattern here, which is good. That means, similar to our correlation coefficient, that we chose a good model to represent our data. Now we can do this on the calculator as well. We're going to go back to stat plot, so second stat plot. We're going to go down to plot 2 and press enter. We want to turn plot 2 on. We want it to be a scatter plot still. We want our x list to be L1. And we want our y list to be the residual. If it's not there, you press second stat and you enter in the residual. Again, you can change the colors here, it doesn't really matter. And we're going to graph them at the same time. Now, we already have our equation in y1 for our linear regression. We already have our data points for this scatter plot in L1 and L2, and now we also have the residual there. We're going to graph all of it. Now when you press zoom 9, which is zoom stat, we can see this is our scatter plot, the red points. The blue line is our line of best fit, And the green points are the residuals that represent how far each point is from the line of best fit. Notice how close they are to this is the x-axis. That's what you want. When they're close, when these numbers are relatively small, so 0.47, negative 3.97, these numbers are relatively small, that means that there's not a huge difference between the data points and the line of best fit. That is exactly what we want to show. There are times where you'll be asked to graph them both, perhaps on the same graph. Usually you're asked to graph one or the other. So now to talk about residuals a little bit. The biggest thing to understand with residuals is that when you plot them, first of all, they should be relatively close to the x-axis because you want them to be small. You don't want the residual to be 24. You want it to be a small difference for most of the points. But you want there to be no pattern. So you can see in this first example that there is absolutely no pattern to these residuals. That's good. That means that you chose a good model to represent your data. However, when the residuals are in a pattern like this, see how it kind of makes the shape of a parabola? It kind of looks like a quadratic. One of them is opening upwards, one of them is opening downwards. When the residuals follow a pattern, that means you did not choose a good representation for the data that you were given. In later chapters, we're going to talk about not only linear regressions, but quadratic regressions, where the data fits into that U-shaped parabola, as well as exponential regression. So there's going to be different models that work better with different types of data. And this will be one way that we determine whether or not we picked a good representation.